702 and Cape Talk.
The Naked Scientists.
Chris, good morning. It's been a couple of weeks.
It has. Good morning.
It is cold in Joburg, which is a beautiful segue into our science story that the common cold might have a possible cure coming.
Well, let's hope so. This is a very interesting story where researchers at Imperial College in London reckon they've invented a molecule that can block the growth of rhinoviruses, which are one of the leading causes of the common cold. Now, it's a serendipitous story, this one, because what Roberto Solari and his colleagues were doing was actually trying to make a drug to treat malaria, because they realised there's an enzyme in malarial parasites which adds a fat molecule onto certain proteins, and it's necessary for malaria to grow. So they were trying to make molecules that could block that. They were trying to block just the malaria and leave the human form of the molecule, the enzyme, untouched. Unfortunately for them, when they were treating malaria, some of the molecules they made actually hit the human cells really well. And what Roberto Solari realised is, well, actually, if it works in the human cell, perhaps because viruses need to use our cells to grow, and some viruses use our enzyme to help the virus to grow, perhaps if we block that enzyme, we'll block the virus. So they grew some cells from airways, human cells, in a dish, infected them with rhinoviruses, and then they added some of these new molecules they'd made, which block the enzyme myristoyl transferase, and this adds this fat molecule onto the growing, developing coat of a rhinovirus. And what they found is they could completely, to nearly 100% levels, block the growth of these viruses in the cells. So they're saying these cells appear to tolerate this blockade for a few days, which is how long roughly you'd need to treat a person with a cold for. So it doesn't seem to have a high side effect risk profile. And it could potentially be administered via the aerosol route. So you could, say, have a nose spray or an inhaler, which would get the drug only into the cells in the airway, not around the rest of the body. And it's not something you'd have to take for a very long time. So they think, obviously it's just the beginning, this is very early days, it's in a test tube and in a culture dish at the moment, but they think they might be on the edge of trying to find a whole new generation of antiviral drugs that could potentially give us that long sought after cure for the common cold.
That's fascinating. By the way, just out of interest, for those of us who are non-science experts but love the world of science, courtesy your lucid teachings every week, is there a book on serendipitous science? Because it seems to me that so much in science often happens with serendipity.
I think you should write one if there isn't. I mean, many of the most popular texts and most popular science stories or inventions begin with someone actually making a mistake. And then they realise that the mistake they've made actually holds the key to solving a much bigger problem. Here's a lovely example, but there are many. So I'm sure that people have begun to pull these sorts of examples together. But if they don't, I think you're onto a killer idea there, Eusebius. And should we co-author it?
I'll happily do so. I'll be second author. I'll just do the journalistic bits. Dave, good morning to you. What is your question for Chris?
Yes, my wife the other day was asking me, and it really irritated me because I'm a real doctor, and I didn't have an answer for her. And then I said, the next time I caught your program, I'll ask you because you know everything.
And what do you want to ask from one doctor to another?
She said to me, she's been going through like a whole pile of sneezing recently, like almost like seasonal atopy, rhinitis, that kind of thing. And but yet when she lay down on the bed or during the night, she's not sneezing during the night, but as soon as she wakes up and starts walking about, she starts to sneeze, and I didn't have an answer. I didn't know.
Okay. Dr. Chris, can you help Dr. Dave?
Well, I don't know the answer, Dr. Day, but I'm going to make a speculation. There's a number of different possibilities here. One is the simple mere fact that when you're in bed at night, you're laying recumbent and you're breathing less, so perhaps your exposure is less. You may also, if you've got a partly blocked up nose because you're having rhinitis, because of allergy, you may be mouth breathing, which means you're less likely to deposit the things into your nose and make yourself sneeze. And also, when you're inside the house, asleep, I presume you're sleeping in the house, not in the garden, then probably your exposure to the allergen may be reduced. If the allergen is something in the environment and it's less in your house, then it may be a combination of all those things or just that one thing that is leading to a reduction in symptoms. And of course, when you are asleep, you are breathing less, so therefore all of these reactions are going to be a bit less pronounced. So I think it's probably a combination of those things.
Bongani, good morning.
Hi, morning, Eusebius. Hi, Naked Scientist. I just want to know how come our flammable liquids and gases, or how come they feel cold?
Hello, Bongani.
Thanks, Bongani.
Very, very good question. The reason they feel cold, and in fact, if you take some, say, whiskey or vodka, you wouldn't want to waste much of it, of course. You want to drink most of it. But if you put a small amount of this on your skin and blow across it, it will feel cold. If you put a small amount of water on your skin and blow across it, it will feel cold. The reason they feel cold is these are volatile liquids. And as they evaporate, they go from a liquid into a gas. And this involves, in a number of cases, breaking bonds or associations between the molecules, which requires energy, and that causes you to rob the energy from the environment or your skin. And as you rob energy from the skin, the temperature goes down. That's actually how sweating works as well. When you sweat, you put a thin layer of water onto the skin. As the sweat evaporates, you're breaking physical interactions between water molecules to make water vapor or gas, and that's very spread out, so there's a very big increase in what we call entropy, so it's energetically favourable for that to happen. But as it happens, you take latent heat of evaporation from the surface, and that's it robbing energy to put into the molecules to break the association so they can spread out into a gas, and that's why those things feel cold.
15 minutes after 10. This is, of course, the Naked Scientist. Call us if you have a question for him. 011 8830702 in Joburg. And Cape Townians will take your question on 021 4460567. Mava and Megan, don't forget the cheap seats. Any SMS questions there? 31567 or 31702.
702 and Cape Talk.
The Naked Scientist.
And of course, also on Twitter, I'll pick up some of your questions there as well. But in the meantime, let's go to Linksfield. Brian, welcome to the show.
Hi, morning. I want to know, there's been a lot of articles recently about near-Earth objects impacting Earth, and they said the scientists would send up a space rocket and they could knock it off its orbit, but it's quite a lot of energy to impact it. Why don't they go up behind the meteor and speed it up? Surely if they could just speed it up by 3 or 4 kilometers by time it's on an impact course to Earth, it would either be early and miss Earth.
Okay, Chris, did you understand that? Did you get that?
Yes, hello, Brian. You're referring to what we call near-Earth objects, or NEOs, and this is the concern that in the same way that the dinosaurs were probably wiped out about 66.5 million years ago by something extremely large slamming into the Earth, creating a big disruption in the climate, plunging us into the asteroid equivalent of a nuclear winter, and that's why the dinosaurs couldn't live here anymore. We're worried that perhaps history could repeat itself. We know this has happened many times in Earth's history, and there are objects out there which could end up on a collision course with Earth. Now, our solar system's more than 4.5 billion years old, which means that it's fairly mature now, and most of those objects have actually been cleared and slammed into things or sunk into the sun, hit Jupiter, and some of them have landed on Earth. One of them was actually planet-sized and produced the moon about 4.5 billion years ago. So the likelihood of it happening is quite remote, but that doesn't mean if you say that it can't ever happen. So there is an active program to look for near-Earth objects, and space agencies in many countries do scrutinize the skies quite carefully. They have a map and they are tracking objects which could end up on an Earthbound course. At the moment, there are none that they're particularly worried about. That said, there could be some stuff in deep space, or there could be some interactions gravitationally that we're not actually aware of, which could bring things onto an Earthbound course. Were that to happen, are we prepared? Well, people do have some ideas, and in fact I interviewed a couple of NASA astronauts about 10 years ago who'd come up with a very intriguing idea to do something a bit similar to what you're suggesting, which is they had the idea for an asteroid tractor. Now, the way their invention worked was that if you knew something was coming way into the future, because obviously we know the movement and the trajectory of many of these objects, so we can plot where they're going to be. If you were to send a big spacecraft to meet one of these things, it doesn't have to be huge, it just has to be a reasonably massive object, as in have some mass. If you maneuver your spacecraft reasonably close to the object, you could allow gravity to do the work. you'd only need a small gravitational attraction between the two, and you could deflect the course of the asteroid a tiny amount, but given enough time, you could actually completely divert it away from an earthbound course, and this would be a much safer solution than doing what films like Armageddon have suggested, where you send up nukes and blow these things up, because all you do if you blow them up is you turn one problem into about 10 million problems, all moving at thousands and thousands of kilometres a second, all of which could do damage to the Earth. So much better to keep it in one giant chunk and try and deflect it gently and just plan ahead into the future. So yes, people are making plans for this. Do we have a practical solution we could wheel out tomorrow if we suddenly detected something? Unfortunately not.
From the SMS line, this is an interesting question. I've sometimes wondered, but unlike Bev, I haven't been curious enough to remember to ask you, Chris. So thank you for the question, Bev. It goes as follows, Chris. Chris, if probiotics are living organisms, how can you take them in tablet form, i.e. dead?
Right, hello, Bev. Yes, probiotics is the word used to describe microorganisms in foods and foodstuffs that we swallow with the anticipation that they will make it through into the intestine. This definitely happens in young babies, and there is evidence that if you give people in hospitals probiotic yogurt drinks, for instance, there are various products you can drink that contain these bacteria, you can help to offset some of the disadvantages of taking antibiotics, for instance, getting things like C. diff infection. The question's always been, though, how do these bacteria make it through the stomach acid? And the evidence is that not many do, but some do, and they help to redress your microbial balance in your intestines. Now, when you swallow these things, they don't kill the bacteria in the capsule. You have to swallow viable live bacteria. And in fact, some people are dubbing these things crapsules because the capsule contains the organisms that are in crap. The other way you can adjust the microbes that live in you, and this may be also what you're thinking of, is there's an effect called a prebiotic effect. And this is where you eat food that then has a secondary effect of manipulating the microbes that live in you. One very good way to do this is to eat your porridge in the morning, because porridge has a very powerful prebiotic effect. There are lots of beta-glucans and other carbohydrates in there that adjust or manipulate or encourage the growth of some microbes, and they suppress the growth of others, and they do it in a way that is actually compatible with good health. So you can have both a prebiotic effect where you encourage the growth of the good bugs, and a probiotic effect where you actually physically swallow some good bugs like lactobacilli and that kind of thing, and together these effects can actually benefit your bowel bacteria.
Absolutely fascinating. Let's go to Bantry Bay. Steve, thank you so much for holding on and welcome to the show.
Thank you. Thank you very much for taking my call. I was wondering the other day, we've got quite a few desert islands or islands with no water on around our coast in South Africa. And I was wondering, how do the seabirds and the seals in particular, where do they get their moisture from? Those huge big animals lying in the sun all day. Surely they must get very dehydrated.
Hi, Steve. Well, I'm not an ornithologist, and I suspect that there'll be people who know a lot better than me the answers to this, but I will speculate several things. One is that in the same way you could ask the same question of marine mammals like dolphins and whales, which never set foot on dry land. They never actually have access really to any fresh water. So how do they cope? Well, one is that many of these animals that are in dry environments or in salt-rich environments have adapted in various ways. If you're a desert shrew, for example, you have kidneys which have much more profound concentrating power to scavenge back water from what's in their urine than a human does, so they are very careful with their water. That's one thing. And similarly, some animals are very good at shedding excess salt, so those marine organisms can actually pee out extra salt, or they can shed salt through their gills, for example, if they're a fish. Birds, on the other hand, well, what do? They might catch fish. They've got to eat something, so they'll catch fish. They therefore can acquire water via their diet. They may also get water from some of the things like grasses that they eat. Geese, for instance, eat lots of grass. That's got lots of water in it. So these animals will be adapted to the environment in which they live because they've evolved to live there, so they've become very good at tolerating that particular environment, and they will exploit the resources available to them to get their water. For instance, they'll eat grass, get it from their diet, and when the dew comes down, when the temperature falls, they can also lick the water off the grass as well.
Oh, absolutely fascinating. It's only 3 minutes after 9. We only have a couple of minutes left with the Naked Scientist, and learning a lot as we always do.
702 and Cape Talk.
The Naked Scientist.
Boosie, good morning. Hello, Busi.
Hello? Hello, you see yes?
Yes, go ahead. The Naked Scientist is listening.
Okay, I just want to know what's the difference between a character and a personality? Because now I'm a person who is crying a lot. Like if something hurts me, even at work, and it's embarrassing, and I can't stop my tears, I cry. And when somebody tries to console me, I cry again. So is there anything that I can do?
I love questions that will stump Chris, but he will have an hypothesis. Chris, we have a big crybaby. What can she do?
And I'm old, you see, dear.
How old are you, Busi?
I'm over 50, and that thing started when I was young, and my previous boss said to me, it's my personality. I can't change my personality.
Well, Chris said that he's not an ornithologist. I suspect he's going to preface his answer by saying he's also not a shrink.
Do you think it's a terrible shame, though, if you show your emotions? Because actually many people argue that some of us are far too stiff-upper-lipped and we don't communicate well enough. So perhaps you could argue that actually showing your emotions and not being afraid to become emotionally happy, emotionally sad sometimes actually helps people to know when they're on the right and the wrong track with people. I think you're to be congratulated, not counselled.
Can I turn it into another question as a follow-up just from me in the peanut gallery? When we do talk about emotions and things like crying, we often do so through the lens of psychology, for example. What does the hard sciences have to say about the purpose of crying, if anything, Chris, in terms of life or evolution?
Sure. Well, humans are social creatures. We are successful as a species because we communicate and we work well together. We're much more powerful when we're a team than when we're an individual. And we also have a very good visual system. More than a third of our brain is devoted just to decoding what goes in through our eyes. Therefore, unsurprisingly, we have evolved mechanisms to communicate that exploit all of the above. So we go red in the face when we're angry, we cry when we're very upset or very, very happy, we make facial gestures, and we talk to each other. And crying is one very visible manifestation showing an extreme of emotion, which means, come on, look, I'm not feeling particularly happy about this, come and help me, or I'm feeling ecstatic about this, come and celebrate with me. Either way, there's a coming together of people, and people tend to get more help and support, which in turn will make the community more cohesive and more successful. That's what the science says.
Okay, that makes sense. Zola, good morning. What is your question?
Yes, good morning. I want to know from Professor there. I've got retinal pigmentosis. I want to know gene therapy is only therapy that is available for people suffering from retinal pigmentosis or other therapies.
Which therapy? Sorry, just slow down a little bit, Zola.
They are saying that the gene therapy that is available for a specific type of retinal pigmentosis, not for all retinal pigmentosis sufferers. So I wanted to know if there is any form of treatment for retinal pigmentosis besides the gene therapy.
Okay.
Hi, Zola. You're asking about retinitis pigmentosa. And retinitis pigmentosa is a developmental problem with the eye, which is caused by a missing gene. And the answer is yes, that there is a therapy, not just a gene therapy. There is a therapy that's being explored in London. And if you want to look this up at Moorfields Eye Hospital, Pete Coffey and Lyndon de Cruz are two of the researchers who are doing this. They're looking at ways to repair the retina, because in people who have retinitis pigmentosa, they lose the ability of the eye to clean up the debris that normally occurs at the back of the eye in the retina, and the accumulation of this debris causes various problems, including poisoning your photoreceptors, your rods and cones. They are developing a way to repair the retinal pigment epithelium, the RPE, which does the important clean-up job at the back of the eye, with a specialised eye patch made from stem cells, and this can be implanted under the retina in people with retinitis pigmentosa. There are also studies on the way where people are attempting to put genes into the retina which will replace the non-working copy and make the retina make the missing gene product, which has the effect of restoring its function. Both of these things are in trials. There's no 100% guaranteed cure yet, but the good news is that people know about this, they know how to find people who've got the condition, and they therefore have several irons in the fire to treat them. And science is moving pretty fast in this space, so I would say watch this space, because I think there's a very good reason to be optimistic.
Let's squeeze in a final question for today, Chris. We've got through quite a lot today, which I'm chuffed about. Lots of people calling in as well. Joe, you have the final question. What is it?
Yes, guys, thank you very much. Love the show. I'm quite an avid surfer, but I've had a few run-ins with sharks. And now these days they sell these shark repellents which use electricity to deter sharks when they come close to you. But I also know that sharks pick up electrical frequencies from fish and other animals that are very faint, and that draws them closer. Now, what I'm wondering is if I was wearing a repellent like that and it's sending out quite a strong electrical signal, if a shark is very far away, would he pick up that signal as a weak signal, and it would actually attract him to come closer, which would put all my buddies at risk?
That's a good thought. Actually, scientists are more interested in looking at how sharks find prey and discriminate between what they do and don't want to eat visually. There is a researcher in Western Australia, in Perth, called Sean Collin. You might want to look him up. And he has made what he calls a shark-proof wetsuit. Now, it's not a chainmail suit made of metal that the shark can't bite through. Actually, what it does, it uses a very similar principle to why a zebra has his stripes. A big group of zebras is called a dazzle, and in the Second World War, ships were painted in garish colours resembling a zebra called dazzle ships, because the idea was that if you have high contrast colours alternating, or black, white, black, white, black, white, it actually is very off-putting for an individual trying to pick this out from a visual scene. That's the theory. It does appear to work, otherwise zebras probably wouldn't have evolved to keep using it. And Sean Collins' wetsuit uses a similar principle of a patterning, which appears to make the individual who's wearing the wetsuit less visible to a shark. Now, I did say to him, when I talked to him, have you tested this? And he said, well, we haven't tested it with people wearing it, because obviously that would be rather difficult to justify ethically, but they have got evidence that this does appear to work. And so the idea is that you can reduce the likelihood that you will become a shark's lunch. So have a look at Sean Collin, Western Australia, in Perth, and his shark-proof wetsuit is a visual design, and is probably going to be a lot more effective using that strategy than, as you say, using electrical signals and so on, because the animals may actually learn that when they see that particular signal or detect that particular signal, that means lunch is on the way. So, in fact, you're right. You may be luring them in. You may have made the best shark lunch attractor rather than a repellent.
Thank you, Chris. Have a beautiful 7 days ahead of you. We'll
Thank
speak
you.
again.
Bye, Eusebius.